So we're going to start off today, we're going to summarize the 3 different ways we can use chi-square. And the first one is the goodness of fit. And so when we're doing goodness of fit, we have a specific H naught that we want to look at, just like in the other ones. And so our assumption here is that the actual population proportions are equal to, the hypothesized proportions. So we have 2 proportions that we're looking at. What we have hypothesized here versus the actual proportion. This is H naught. And we think that what we're going to see in the population is exactly the same as our hypothesis. That's why we call it our hypothesis. And so when we do this test, we calculate all the differences. Again, down here between observed and expected, we square them, divide by the expected, and that gives us a chi-squared value. Now, when we do this particular test, our degrees of freedom are going to be n minus 1. So we're going to do an example of this where we find the goodness of fit. So our example is going to be problem 13.4 on page 737. So in this, they're looking at an effort to enable more members of minority groups to have increased educational opportunities. And they're comparing the year of 1981 to a sample of doctoral degree recipients in 1994. So it's already designated on your page right here at the bottom. So you have 1981 versus what year? You got it. That's correct. And the categories that this study used, which personally I'm not a fan of dividing people up into racial categories, but that's a side note. Okay, that's a side note. So they used white and black, non-Hispanic, Hispanic, Asian or Pacific Islander, American Indian, which I believe change, and then include Alaska Native, non-resident alien. They kind of grouped many together there. So these are our different categories, right? So we're going to try and ignore the social commentary about dividing people up by social category. But the goal here was with good intentions. They were wanting to make sure that people were not discriminating and that there was not a disproportionate number of people being denied access to education. So we have the percentages in 1981. So we can list each of those. We can see it's dominated there. This was the number of people who obtained the highest academic degree, Doctor of Philosophy or PhD. So almost 79% were white, 3.9 black, and so on. 1.4, 2.7. I would suggest you write it down, Drew, just to call you out by name in the video. Okay. All right. And then we have 1994. right? Which are comparing the exact same thing. But over here, in this case, it was a percent. In this case, it was a count. So there were 189, 10, 6, 14, 1, and 80. And it would be nice if I had it in somewhat of a table. And non-resident means they don't live here. So they received a degree, but what's going on here? Non-resident means they attended the university but don't live here. So they came, went to school, and then left. It has no connection to any particular country. Drew. Okay. All right. So now, what we want to do is compute chi-squared using the formula up above, right? It's the observed minus expected squared over the expected. So I'm going to stop the video here, and I would have you go through. You can use lists, creating one list for the observed, which would be over here. This is what we saw, and use the percents from 81 as what we would expect. And we're trying to see, did the population act in exactly the same way it did in 1981?